Welcome back to part 2. Today, now that we know how to graph sine and cosine, we're going to do some transformations, which means we're going to change the amplitude, the period, and the PS, which is the phase shift. Okay, so let's get started. Here are the transformations. Now, the good thing is we already know what all of these transformations do. They're just going to be called something else in terms of trig functions. So A is still our vertical stretch and shrink, but A is going to stand for amplitude. Okay, so if our function is y equals 2 sine x, the max and the min is now 2 and negative 2. That's your amplitude. It's your vertical stretch, shrink. Okay, I'm going to go all the way down to D. D is your midline. And it is a transformation that goes up or down. And it's usually the first thing I graph. So if we had to graph y equals sine x minus 2, I graph a midline and then graph sine. It's a sine function. It's just down 2 with a period of 2 pi. Okay. B is your horizontal stretch, shrink. But more importantly, it's going to affect the period. So your period on sine is 2 pi. If it's transformed, your period is now going to be 2 pi over b, and we'll talk about that a little bit more. And C is your phase shift. It's still your horizontal transformation. But it's got a new name. Okay, so let's put these into action. Let's graph a function. So we're going to graph 3 sine 4 theta. I'm going to start with the amplitude. So it looks like the amplitude is 3. So I'm going to mark 3 and negative 3 on my graph. I usually start with the vertical change, but it doesn't look like there is one. So we'll go ahead and go to the next step. And then we have to figure out the horizontal compression. As you can see, there's a 4 here. And in our previous work, we know that if the number is bigger than 1, it's going to be a horizontal compression instead of a stretch when it's on the inside of the function. Okay, so what is that going to look like? In the past, we've struggled with what kind of transformation to do first when it's horizontal. So I like to do this method to graph trig functions. So sine has a period that goes from 0 to 2 pi. So you have to know the period of each of the trig functions in order for this to work. And then I take the horizontal transformations, all of them, in this case it's just 4 theta, and I drop that right in the middle of this inequality. And then I solve for theta. So divide everything by 4, and I get 0 is less than theta is less than pi over 2. So this particular function has been horizontally compressed by 4. If you take 2 pi and divide it by 4, you get pi over 2. Okay, that's step 1. Step 2, I need to figure out how to put my 4 markings. And the easiest way is to take your new period, which is pi over 2, and multiply it by a quarter. And then you'll know how to mark off your horizontal axis. So I'm going to go pi over 8, 2 pi over 8, which is pi over 4, but I'm okay if you don't reduce, 3 pi over 8, and 4 pi over 8, which is pi over 2. Okay, so sine starts at 0, 0, and then I just mark the sine function. Okay, going through the rest of this slide, the period is 2 pi over b. Our b again is 4. 2 pi over 4. Our period was pi over 2. And the phase shift is, if there was a phase shift, it's this C part. That's your phase shift. Were you moving right or left? In this case, we didn't, but we do on the next one. So let's move on to our second example. So just to remind us, if we were to graph cosine, cosine starts at 0, 1, and then it came back down to the midline, down to -1, midline, and then up to +1. So it looked like a U. So we're going to take that function and we're going to reflect it over the x-axis, give it a vertical stretch of 2. We're going to change the period, and we're going to give it a phase shift. So if you can imagine, that U is going to be upside down and looks like it's going to be a little skinnier. Let's figure out by how much. So first, our amplitude is 2. Remember, we don't use the negative, so it's just 2. Our period, because it's cosine, we're going to take 2 pi and divide it by that b. So our period is going to be half the length. It used to be 2 pi, now it's just pi. There is no vertical shift. That would be a number on the end, like a +5 or -2, but there is no number there. And then the horizontal shift, we're going to figure that out separately. So I'm going to switch back to black, and I'm going to use the period for cosine, which is 0 to 2 pi. And then I'm going to take our horizontal transformations and drop it right in the middle of this interval. And now I'm going to solve for theta. So I'm going to add pi to both sides. This just helps alleviate trying to figure out which transformation you do first. This will tell you where to stop and where to start. So it looks like my function starts at pi over 2 and it ends at 3 pi over 2. This is your phase shift. The pi over 2 is your phase shift. It's going to move right pi over 2. Normally it starts at the y-axis, and it's going to end at 3 pi over 2. Now we know the period from our previous work is pi, and it makes sense if you start at pi over 2 and you add pi, you'd end up at 3 pi over 2. The last thing that we need is the increments. And in this case, we're going to need 5, because normally we start at the origin or at the y-axis, but this has a phase shift. So I'm going to try to mark 5 even marks on my graph. And the increments, you take your period and you multiply by 1/4. So we're going to have increments of pi over 4. Okay, so I know my start. I'm going to highlight my start is at pi over 2, and my end is 3 pi over 2. So I'm going to mark pi over 2 and 3 pi over 2. And then the increments in between are pi over 4s. Now, if you think about pi over 2 as a pi over 4, that would be 2 pi over 4. So I'm going to pretend that's a 2 pi over 4, and I'm going to add pi over 4, so I get 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, and 3 pi over 2 is 6 pi over 4. Okay, now I know my amplitude goes to 2 and to -2, or my cosine graph is going to go in between 2 and -2. Lastly, remember what your original function looked like for cosine x. We're going to take that function and we have to reflect it over the y-axis. So instead of starting at +2, it's going to start at -2, but it's going to start at -2 pi over 2. So there we go. It's going to start at -2 pi over 2, and then it's going to go 3 pi over 2, 3 pi over 4 midline, up to 2, back to the midline, down to -2. Okay, on to example number 3. So as you can see, we have almost all of the transformations here. We have an amplitude of 6. We have a period of, it looks like 2 pi. There would be a number in front of here. There is no number in front of that theta, so it's just 2 pi. It looks like we have a horizontal shift of negative pi over 6. And it looks like we have a vertical shift of negative 2. I like to start at that vertical shift of negative 2. And I made these a little too big. So let's mark like maybe right here as negative 2. And I like to put a little dashed line through here to remind myself that that's going to be my midline. Okay, and then I like to mark, if my amplitude is 6, I'm going to go 6 above and 6 below that line. So 6 above negative 2 would be at 4, and 6 below negative 2 would be at negative 8. So I like to start there just to remind myself, excuse me, how high and low it's going to go. Okay, and then I'm going to take my period for sine, which is 0 to 2 pi, and throw in theta plus pi over 6. So I know that I'm going to start at negative pi over 6, and I'm going to change 2 pi is 12 pi over 6. If I subtract pi over 6 from 12 pi over 6, I get 11 pi over 6. Next, I have to figure out my increments. So I'm going to take my period, which is 2 pi. I'm going to multiply that by my quarter increments, so that would be 2 pi over 4, pi over 2. Okay, I'm going to change that to 3 pi over 6 since all of my numbers are already in pi over 6. So it looks like I'm starting, that's my phase shift, at negative pi over 6. And I'm going to add 3 pi over 6 to that. So if I added 3 pi over 6, I'd be over here at 2 pi over 6, and then 5 pi over 6, and then 8 pi over 6, and then 11 pi over 6. Okay, so remember our parent function for sine looks like this. So we're going to take that function and transform it. So I don't have any vertical reflections. So it looks like I'm going to start on my midline at negative pi over 6. And then I'm going to be up at 4 at 2 pi over 6. Midline again at 5 pi over 6. I'm down at negative 8 at 8 pi over 6. Seems a little low. Let's try that again. And back to my midline at 11 pi over 6. Okay, so that concludes our first day of transformations. We're going to do this again on day 2. There is a short PDF that follows this that I'd like you to try, and I will have a key in the key folder for you to check your work. Nice work today.